Hey everybody, it's Mr. Carr again. Today we'll be talking about 6A Day 2, solving what's called compound inequalities. Okay, so let's first talk about how to define that. So a compound inequality, it is relating two inequalities with the same variable. Okay, so it relates two inequalities with the same variable. So I'm going to use X in both cases, or use Y or whatever it is, but we are referring to the same number when we talk about the same variable like that. Okay, we can connect them. We relate them by one of two ways. We do an or statement or an and statement. Okay, so we're going to talk about the ors first. Solve and graph compound inequalities with or. When we talk about an or, the graph of this is going to be a little bit different than what we did before with our inequalities. Instead of just having one dot or circle and then just a single arrow, we're actually going to have two of them. We have two possibilities here. Okay, X is less than -5. So remember, with the less than, we're going to have an open circle. X is greater than 0, we're going to have an open circle there too. In this order, less than is going to point this way and greater than is going to point this way. Okay, so when we look at this, we're going to have an open circle on -5, and then an arrow to the left, and an open circle on 0, and an arrow to the right. So with an or statement, we're looking for just any number that works for one of these. Okay, so with an or statement, for example, we look at 2 here. If I test that out, is 2 less than -5? No. Okay, but is 2 greater than 0? Yes. So that's why 2 is a solution here. Okay, these are solutions both in here and here. So all I need is for it to be true for one of the two inequalities, but not both in this case. All right, but let's look what happens if I pick something like -3. -3 is not in the solution set, so let's take a look at that. Is -3 less than -5? No. Is -3 greater than 0? No. That's why it's not part of the solution. It is not true for either of the statements. For the next step, for example 2, hold on, we're a little bit frozen here. Yeah, check that out. There we go. Okay, so for example 2, we got these two possibilities here. This works just like we did with our inequalities before. We're going to solve these, but we're just going to solve 2 of them. That's all. And then we're going to graph those both inequalities on there. So I'm going to start with subtracting 3 to both sides. So 4x is less than 8. And we can divide both sides by 4 so that x is less than 2. Over here, I'm going to add 4 to both sides so that 3x is greater than 12. Then we can divide by 3 so that x is greater than 4. Remember, this was an or statement in between. So now that I have an or statement, x is less than 2. That's going to get an open circle on 2. And less than means I'm going to go to the left. X is greater than 4. That's going to get an open circle, and I'm going to go off to the right. Okay. And that's it for these. We're just going to solve them as our individual inequalities and then graph those two inequalities at the end. So we got here for 3x plus 1 less than or equal to 4. I'm going to subtract 1 on both sides. 3x is less than or equal to 3. Divide by 3. X is less than or equal to 1. Over here, I'm going to add 5 to both sides so that 2x is greater than 12. Divide by 2, and x is greater than 6. And remember, this is an or statement still. Okay, x is less than or equal to 1, so that's going to get a closed circle. And that's going to be to the left there. X is greater than 6 is going to get an open circle, and that's going to go off to the right. Okay, don't forget the other rule. If we divide by a negative number, we have to flip the sign. So that still applies with our compound inequalities. All right, now let's talk about the and statement. When there's an and inequality, the solution is where the shaded, I don't like that. Let's say overlapping. That's a little bit better. The overlapping region is, okay? And what that means is when we look at this one here, so graph the compound inequality here, x is less than 5 and x is greater than or equal to 0. So let's take a look at both of those two separately to start. X is less than 5 is going to look like this. It's going to be an open circle on 5 and off to the left. X is greater than or equal to 0 is going to get a closed circle on 0 and it's off to the right. So we look at these ideas here. An and statement means both inequalities need to be true. So let me pick a few numbers just to look at these real fast. So for example, I'm going to pick -3, 2, and 7. Okay. Is -3 less than 5? Yes. But is -3 greater than or equal to 0? No. This is where and statements are different from our or statements. This is not a solution. -3 is true for one of them, but not both. It has to be true for both of the inequalities. So let's try, what did I say? 2. Is 2 less than 5? And is 2 greater than or equal to 0? So this is a yes, and this is also a yes. Okay, that's why 2 is part of the solution here. So this one right here is a good one. And then 7. Is 7 less than 5? And is 7 greater than or equal to 0? This is a no, this is a yes. So that's why 7 is not part of it. So this is the actual solution set here. It's the overlapping region. You can see here, kind of like this little box here. Those are the numbers that show up in both, except for 5, because 5 is also going to be true for one of them and not the other. Because if I plug in the first one, is 5 less than 5? No. So the actual solution, I'm going to put a closed circle on 0, open circle on 5, and it's just this. That's it. This is my actual solution as a graph. So and statements are typically going to look like this. They're going to be a shaded region in between two circles or 2 dots or whatever. Okay. So when we do this, we're still going to do the same idea. Okay. Solve and graph these, graph each of these. We're going to solve them separately. So to start, I'm going to divide this by 4. So 3 is greater than x. Oops. Okay. Here I'll subtract by 5. -5x is less than or equal to 20. Divide by -5. And just like I said earlier, we're going to flip the sign because we're divided by a negative number there. So instead of a less than or equal to, it now turns into greater than or equal to. Okay. To make this a little bit easier, I'm going to reverse this one. Okay. Because remember, when we do our graphing, it's a little bit easier if the variable's on the left side. So if I do that, it's going to read like this. 3 is greater than x. X is less than 3. Okay. And these are and statements. So 3 is going to get an open circle. -4 is going to get a closed circle. And less than is going to go to the left. And then greater than is going to go to the right. So really, it's just the shaded overlapping region there. Okay. And that's it for there. Part B is also an and statement. It's just written a little bit differently. Okay. So when I do this compound equality where there is no word in there, this is actually the same as doing this. -19 less than or equal to 2 plus 7x and 2 plus 7x less than 44. Okay. So if you absolutely want to, you could just split them up and do exactly like we just did. Okay. Like on the previous example, we have 2 separate statements. We solve them individually, and then we just make sure it's written in this order. And that way we can just do that. Okay. So yeah, I'm just going to stick with that. You know what? We're going to make it a little bit easier on ourselves. We're just going to go ahead and stick with that idea. So split them up. And now let's go ahead and solve these. So I'm going to subtract 2 to both sides. So that's a -21 less than or equal to 7x. Divide by 7. I get -3 less than or equal to x. Over here, subtract 2 to both sides. 7x is less than 42. Divide by 7, x is less than 6. Okay. And remember, this one right here, this is a little bit easier if I flip it around. So I'm going to make that x is greater than or equal to -3. And x is less than 6. So -3 is going to get a closed circle. 6 is going to get an open circle. Greater than -3 is going this way. Less than, whoops. Okay, less than 6 is going to go to the left. So that's that overlapping region right there. All right. So that's a little bit easier on that one. If you really wanted to, you can actually kind of put it back into this same compound inequality. So the way that works is like this. If I look at this version right here, okay, that can kind of combine, because if it's -3 is less than or equal to x and x, let me put that and in there, and x is less than 6, then that can also just combine into a compound inequality that looks like this. Okay, so these two ideas right here, they mean the same exact thing. So x is greater than or equal to -3 and x is less than 6. Same thing as saying -3 is less than or equal to x is less than 6 and x is less than 6. Okay, so they both work, they both mean the same thing. So you notice in this graphing, I like to just point this out. If I have it in this order and my symbols are all both in the less than direction, then -3 and 6 are my like kind of two endpoints, and I just shade in between. So as long as you set it up that way, you can do it in this scenario here. Okay, that is it for 6A day 2. That's it for our compound inequalities. So as a reminder, two possibilities. We have an or statement, okay? And these are solutions that are just represent one of the cases, not necessarily both that are true. So as long as we have a number that works for one of them, that's a solution. But then there's also and statements, which have to be both are true. Okay, so like on this one, this was not a solution, but this one was a solution. All right. And our solving, we just do our normal steps like we did way back in like unit 2, but we just deal with our inequality rules. That's all. All right. That's it for today. Take care, everybody.